Today we are doing lesson 2 in module 2. It's on page 13. It's adding integers with a number line. For the lesson today, you're only going to need paper, pencil, and your module. If you don't have these items, hit pause and go ahead and get them. You need to copy these notes. If you need to pause the video to copy them, please do so. Alright, to add integers using the number line, count up means you're adding a positive number, you're going to move right. Count down means you're adding a negative number, you're going to move left. You always start at 0. The first line goes at the very bottom next to your number line. That's your first number. Your second number goes above that. Your third number goes above that. So each number has its own line. The ending point is going to be your answer. Vocabulary today, a vector. We're going to do a straight line instead of loops. That straight line is called a vector. It has two things. Direction, it goes right or left. And magnitude is how long it is. The length of the line is called the magnitude. It's the absolute value of that number. Commutative property means that the order changes. 3 plus 6 is the same thing as 6 plus 3. So even though the order changes, the answer does not. Alright, that's the end of your notes. Feel free to stop your video if you need to. Alright, now turn to page 13. Let's work the first problem. So it says, answer the questions below. Suppose you received $10 from your grandmother for your birthday. You spent $4 on snacks. Using addition, how would you write an equation to represent the situation? Alright, if you received $10, that means it's positive. And since we're only doing addition today, it may seem like you're actually subtracting 4, but since we're doing addition, you spent 4, so we're going to add negative 4. Now, since they want you to write an equation, that means it has to have an equal sign. The word equal is in equation. That's how you know that. So let's find the answer to that. To find the answer, I'm going to start at 0. I'm going to draw my first one. It's positive. So my vector is going to the right. It has a magnitude of 10 because it's 10 units long. Remember, when you make the second number, you start at the end of the first number. So I have to go forward to the left because it's negative. So I'm going to loop underneath so you can see it. So there's 1, 2, 3, 4. So my line's got to go to right there. So this is the ending point or the answer. So 6 will be the answer to that problem. You can work all of these addition problems on the number line. It's easier though if you just memorize the rule for how to do it, because sometimes the numbers are very large or there's a lot of them. Makes it a little hard to do it on number line. Alright, go to the second example. They want us to answer a bunch of questions and then work that problem. So the problem is, complete the steps to find the sum, that's your answer, to negative 2 plus 3. Alright, so by filling in these blanks, and then we're going to do it on the number line. So you start with the tail of the arrow is always going to be on 0. Your first number is negative 2, so you're going to draw the arrow 2 units to the left because it's negative, and you're going to end at negative 2. So the direction is left. Start the next arrow at the end of the first arrow or at negative 2. Draw the second arrow. Since the second number is 3, we're going to go 3 units to the right. Since we're counting up, we're going to the right. So then we're going to stop at the answer. So let's go ahead and work that so we can see where we would actually stop. So I'm going to start at 0 and I'm going to go to negative 2. So 2 left. My direction is left. Magnitude, that arrow is 2 units long, so the magnitude is 2. It's the absolute value, so it doesn't matter if it's positive or negative, it's just how big it is. So at -2, now I'm going to go 3 units to the right. That's going to take me right here. So my answer is 1. Circle the number which the second arrow ends. It would be 1. So your page needs to look just like my page. Alright, we're going to do the same process, but we're not going to fill in all his answers. We're just going to work the problem this time. So the problem this time is 3 plus -2, which looks a little familiar. So my first number is 3, so I'm going to go from 0. It's positive, so I'm going to go right. My direction is right. My magnitude is 3 because that arrow is 3 long. Now I have to go left because it's negative. So 1, 2 to the left. I'm going to end up at 1, which is the same thing that I had on the last problem. So what can you say about the sum of -2 plus 3 and 3 plus -2? They're the same. Does the order matter? The order does not matter because of the commutative property that says you can change the order. So you can only change on addition, you can't do it on subtraction. So what I want you to do now is go to example 2, and we're going to talk a little bit about it. So remember when you have those little field goal kind of bars right here, that means absolute value. That's going to be your magnitude. So how does the absolute value determine the arrow length for -2? So I'm going to go from 0, negative means I have to go left. So this thing is 1 too long. So how does it help you with that? It tells you how long it should be. So B, how does the absolute value determine the arrow length for 3? So I'm going to start at 0, go to 3. So this is 3 long. So it doesn't matter if it's positive or negative. It's going to be just the number. It's never going to have a negative answer. Describe how the absolute value helps you represent -10 on number line. You know the absolute value of -10 is 10. So you know the magnitude of that line is going to be 10. So it's 10 units long. Alright, I want you to try to work some of these on your own using the number line. So go ahead and pause your video and you can try to do A and B and then come back and we'll work them together. Alright, so the first one I'm going to have to start at -6. So remember my starting point is always 0. Since it's -6, I'm going 6 units to the left. So the magnitude is 6. The direction is left. Now from that, I'm going to go 4 units since it's positive. I'm adding +4 to the right. 1, 2, 3, 4. So I know my arrow is going to end up right here. So my answer is -2. So notice this thing says create a number line model to represent each of the expressions. They're expressions because they don't have an equal sign. Remember, if it has an equal sign, it's an equation. Alright, B is 3, so I'm going to go, it's positive, so I'm going to go right 3. And then it's plus -8. So I'm going to count my places. So there's 1, 2, 3, 4, 5, 6, 7, 8. So I should end up right here. So my answer is -5. So hopefully you're starting to see the pattern for how you actually add these. Alright, we're gonna do example 3 together. So they have a problem on this number line, and you're gonna answer questions about this problem. Write an equation to express the sum. So I know there are 3 of them, and I know it said write an equation, so I need to have an equal sign. So it's some number plus another number. Alright, the first number is the one that happens on the very bottom, so it's positive 5. The second number is right above that, so it's negative 2. Sometimes they'll put negatives in parentheses. It doesn't change anything. It's just because they want to separate it from that plus sign. The last one is 3. Alright, we're going to solve that together in a second. Alright, so skip B, it talks about the cards. We don't really have the cards, so we're going to skip that. Alright, so C says, in what ways does this model differ from the ones we used in lesson 1? So if you remember back to lesson 1, what was different was we had loops. This one has straight lines. Or vectors. We're not using loops anymore. Can you make a connection between the sum of 6 and where the third arrow ends on the number line? Would the sum change if we change the order? Well, we know that the sum doesn't change, and we'll come back to D and we'll solve that. Would the diagram change? Yes, the diagram would. But let's go back to this. So where it ends up, the last one ends up on 6. So that's what they're talking about. Can you make a connection between the sum of 6 and where the third arrow ends? The third arrow ends at the sum of 6. That's the answer. Alright, so if we changed it to this, the first one would be negative 2. Well, our first one was 5. So the diagram would change, and our second one would then be 3, and our last one would be 5. So yes, our diagram would look totally different, but the answer would remain the same. All right, how can you use a number line to model and find the sum of negative 8 and 5? You draw a vector that goes from 0 to the left to negative 8, and then you would count to the right 5 places and see where you would end up. What does the absolute value tell you? It tells you how long to make your line. It tells you the magnitude of that line. All right, go to your exit ticket. Go ahead and hit pause on your video and work the exit ticket, and then come back and we'll work it together. Alright, the exit ticket has a little problem worked for us. It says Jessica made the addition model below the expression negative 5 plus negative 2 plus 3. Do the arrows correctly represent the numbers that Jessica is using? So I'll just look at the first one. First one is negative 5. That means I should start at 0. Go to negative 5, and I'm going left. So my arrow should be right here. So I don't even need to go any further because I know, no, it's not right. Jessica used the number line diagram above to conclude that the sum of the 3 numbers is 1. Is she correct? So in order to see if she's correct, we're going to actually work the problem. So the first one is negative 5. So I'm going to go from 0 to negative 5. So direction is left, magnitude is 5. And then I'm going to add negative 2. So remember, that's where they messed up here also. You start at the end where your arrow is. And since her arrow is in the wrong place, everything's going to be wrong on that. So from negative 5, I have to go 2 places left. So now I'm right there at negative 7. All right, then I'm going to add 3, so I have to go right 3. So 1, 2, 3. It's going to take me to negative 4. So is she right? No, she is not. go to the rest of the exit ticket. Oh, there is no rest. Sorry, we're done. I don't care so much about the real world situation. Usually what I say is I use money. So you owe somebody $5 and then you borrow 2 more. So it's plus -2. And then you pay them back $3. So that would be a real world situation for that. All right, hope you have understood this. That was the end of lesson 2. I will see you for lesson 3.